In today's episode of Turn Stories, I talk with Ninad Pundalik about a Postgres migration. It could have been a nightmare, but it wasn't. You might think that upgrading Postgres from 11 to 16 is a series of small, challenging migrations, but that's not what they did. They spun up a new Postgres 16 instance, and they migrated the data over in a single shot. And that strategy gave them a rare opportunity. They mapped out exactly what data was important to the business. They deleted all of the legacy and useless data, and they tuned the new database for Postgres 16 without having to bring all the old operational cruft of the existing system behind. It's a great strategy. This episode is heavy on details, deep in the stack, and in production. Enjoy. Hey everyone, and welcome back to the Turn podcast. Today we've got a great episode with Ninad Pundalik. He's been an engineer he's currently a site reliability engineer at LiveKit. He's worked at companies like Dite and Slack, Astro, and Microsoft. He's worked across the entire stack. And today we're going to talk about his experience migrating some database work. And maybe if we have time, we'll get into some Kubernetes and containerization work as well. So welcome, Ninad.
I'm so happy to be here. It's always fun to chat about work. So here we are.
Right on. Okay, so let's dive right into it. We had been chatting earlier about this Postgres upgrade that you had tackled. Before we get into what you did, tell me a little bit. Set the stage for me a little bit. What stage was the company at? What was the background? How were things when you arrived?
Yep. Yeah. So I participated in this migration as a consultant, and the company is in the travel space. They help folks with booking hotels, flights, and other related services in travel. And they use the website that they have as another channel for their business. It is not their sole channel for business, and as a result, it is an important service for them, but it is not like a critical, this site should never go down sort of a service for them, which is important for the context later on. And the database that they had been using for a while, the setup that they had was they had a bunch of Ruby on Rails applications which talked to a Postgres database, and those ROR applications were running on a Kubernetes cluster. And because the team did not have in-house expertise for development, they had hired a consulting firm who had initially set up the entire project for them. And as time passes, versions change, like seasons change. So eventually the database and Kubernetes versions both reached end of support. And that's where me and a couple of other folks came in, and we tried to help figure that stuff out for them. The first thing that we'll talk about is upgrading Postgres. The Postgres that they were using was an AWS RDS instance, and it was a Postgres 11 instance. It was a single node with... Wait, it wasn't actually a single node. There were 3 or 4 different nodes. Each node had individual databases on it, and there were good reasons for splitting up the workload in multiple databases. When the original site had been written, the performance patterns for a couple of workloads were very spiky, and the other stuff was relatively straightforward REST API stuff, which was hit by humans. The spiky stuff was hit by because this is the travel industry, they end up interacting and interfacing with a bunch of third-party APIs, and Google, as always, for advertising and traffic inflow. And as a result, that part, the API traffic, ended up being fairly spiky. So the team chose to run it in a separate workload at some point of time, in a separate database. But because there were like 4 nodes and all of them costing a decent amount, we decided we'll play around with these numbers a bit. We'll go for a slightly larger instance. And we ended up migrating all of the data from the 3 to 4 different instances into a single node. And for the couple of months that I was part of the engagement after the migration completed, the node was capable enough of handling version upgrades. We went from like Postgres 11 to Postgres 16. So I am pretty sure we had a bunch of performance improvements just from that upgrade, which allowed us to co-locate all of these things. And also it helped with another thing, which is previously we had one database of each workload. Now we could have a standby replica, a cold replica, in case of like a failure for the primary node. So the costs didn't significantly go down. The costs went down a little bit, but we did have much better reliability for the entire setup. So this is sort of the stage. Where do we want to dig in over here?
Yeah. So you were brought in as consultants. Was there were there any engineers at the company who, owned this setup or had familiarity with it, or was this something where you were coming in pretty cold and had to pick up, what had been done
It
from the
was a lukewarm situation. The team had a couple of folks who were from an engineering background. Essentially, there was a CTO in that, even though this was a travel boutique agency, they had a CTO person or a CTO role, and that person had a good amount of familiarity with the code itself, the application code. But then there were a bunch of database tables that were used. There were a bunch of database tables that were not used. That sort of was all tribal knowledge that had been lost. So we had to sort of rediscover it and figure out, hey, this is safe to kill, or there are absolutely no queries here, or this table actually has traffic that is still coming in, and we sort of took calls based on that. So yes, it was a mixture. Some stuff we had support, some stuff we had to figure it out on the go.
Got it. Yeah, a little bit of knowledge helps. Um,
Always.
where so what pressure were they feeling to upgrade? Was there a single reason, or were there multiple reasons that all kind of came together?
The primary and probably the only reason for them to start this entire effort was that Postgres 11, and this is 2024, late 2024 that we're talking about. Postgres 11 was going to be out of support from both the Postgres project itself as well as AWS RDS, which is actually hosting the application, the database application for them. And after a certain point of time, if anything happened to the database, AWS, which is the cloud provider here, would rightly not be able to help them with fixing anything. So that was the only reason that they started this entire thing. The cost savings or the performance improvements that we talked about a little while ago briefly were a side effect of the entire effort.
Nice to have.
There's good side, yeah, nice to haves, but they were not the goal.
Yeah, prevent Amazon from turning off the instance because it's end of life.
Yep,
That's
essentially.
that drives everything. Uh, Amazing. So, walk me through the process and the major milestones. You had 5 versions to upgrade. How did you approach that span of an upgrade?
Uh, I was fortunate enough that just a few months before taking on this assignment, we had done a similar migration at my previous employer, which was Dite, where we had been running Postgres 11, and we did a Postgres 15 migration. And as a part of all of that effort, although I did not execute on that project directly, a teammate had taken care of a bunch of that work. I was with that person for the entire planning and feedback conversations and figuring out prototyping stuff. So I had a fair idea that doing a versioned upgrade, like one version at a time, in place upgrade is going to be super painful, and it's not going to be worth anyone's time. It's usually just easier to spin up another instance and figure out how to replicate data from the old instance to the new instance, and then figure out an application cutover plan. And that's essentially what we did at both the old, at like Dite, and at the company that I was consulting with. And the milestones essentially then were checking, or sort of the checklist that we had in this place was each database essentially ends up having a matrix of what versions are supported, and in that matrix they also say, hey, you can upgrade from A to B, but you cannot upgrade from 1 to 2 or 2 to 3. So you need to get to those appropriate version numbers. And fortunately, because RDS is a hosted database provider, they have generally taken good care of making sure that databases are at a reasonably recent version. the minor versions, not the major versions. So we basically came in, we checked, hey, is the database at the right minor version that we need it to be at? And once we did that, we took a clone of the database, we ran a in-place upgrade of the clone to get an estimate of what the time duration is. And it, of course, validated our earlier hunch that it's probably not a very great idea to do like, hey, spin up a new one and then upgrade that, like spin a copy from a snapshot. It's just easier to have a fresh node. That also sort of helps with fixing a couple of other things. There's always technical debt in any setup, and by having a fresh instance, it helps in making sure all of the database parameters for buffers and query parameters are all sort of relevant to the new major version that you're going into, because major versions are called major versions because these parameters and such behaviors change significantly enough that you want to revisit the assumptions behind that. And the other reason that we wanted to go with uh, create a new empty database at the new version and then replicate data over was, historically a lot of the systems had been set up with infrastructure as code, but that entire repository had rotten off. There was a lot of bit rot, and there was essentially no way that we could reuse any of that code and build out the new sort of infrastructure for both the database as well as the applications. And we elected to spin up new databases entirely. uh, it's easier when you have a new net new application rather than like trying to clone an existing thing. So we essentially spun up, we used AWS CDK in TypeScript because that way made the most sense for the team that we were working with. Underlying
What is CDK?
AWS CDK is the cloud development toolkit, and it essentially is I wouldn't call it a wrapper. It is a generator for cloud formation. It'll let you write code that looks procedural, and it lets you then generate CloudFormation templates out of it. And those CloudFormation templates are essentially still declarative infrastructure as code that we're all used to. So Terraform, Pulumi, a bunch of these are all declarative at the end of the day. Sorry, I'm not sure about Pulumi, but the others are definitely very declarative. And you can use this to build out infrastructure. And CDK as a project supports multiple languages as sort of like a language to write in. There's TypeScript, Python, Go, Java, and there's a couple of other that I don't recall right now. But TypeScript is sort of the first class language in the sense that the actual internal AWS CDK team first develops in JavaScript and TypeScript, and then for all of the other languages they use foreign function bindings, FFIs, and they sort of use that to generate code that is essentially the SDK to use in other languages, which officially all of the other languages are still first class, but it sort of gives them a second class look and feel. So TypeScript sort of made the most sense. And here we coming back to where we were. Check the versions. After the versions are checked, start setting up the new infrastructure repository and use CDK to actually spin up the new database. We took that opportunity to revisit all of the parameters, look at which parameters were necessary for which workloads. This is where we realized that, hey, different databases and different workloads have different characteristics, and there had been tuning that had been done previously to support that. So we copied that over, we figured out how to do that. And in addition, every database replication for Postgres recommends you set up additional parameters which help a lot with managing the write ahead log explicitly, just for like a database replication scenario. It increases the slots available for replication, so on and so forth. So you sort of set up your first line of parameters, which is your application required parameters, and then you have like your second line of parameters which are necessary for just the period of the migration or the data copy. And RDS is going to, of course, like merge them all in, apply them to the DB. And once your migration is done, you can drop the replication specific stuff, but keep the application specific stuff. So we set up the DB, then we did a bunch of copies from the different source workloads. And as with most setups, the staging or the lower environment is not always in a great situation. And cost is always a much more significant factor in the staging setup compared to production. So staging had like one instance with all of the workloads, and production had like four instances with four workloads. So that sort of made replication slightly tricky to figure out. Also, the instructions for setting up instance to instance replication are a little confusing. You can use AWS has its own native service called DMS, or database migration service, which in the background still relies on Postgres copying in a couple of different forms. But that also is relatively opaque. It's not super easy to troubleshoot when stuff breaks. And you essentially have to just restart the entire process, which does not give you a lot of control. So we essentially looked at, give me a second to look the exact notes up, but we used a Postgres native approach for replication. And in the source nodes, we set up targets or subscribers, publishers. And on the target node, we had the subscribers, and we had data sort of get replicated over. Staging happened in the matter of a couple of hours. Production, of course, ended up taking longer, but that's okay. In staging, we also sort of took the easy way out and made sure that just the count of various tables and their rows was sort of similar between the source and the target one, but that was mostly like run a simple query in a SQL shell and eyeball the numbers, and hey, if these are approximately the same, this is good. In production, we essentially replicated the same process, which is use CDK to spin up a production copy of the environment, set up the instance, then manually set up the publication and subscription for replication. But when the replication was close to finishing, I ended up working on a bunch of utility scripts that would connect to the source DB and the target DB, and it would run queries for a bunch of different parameters or metadata. It would, of course, look at the number of rows because that is sort of the primary indicator of, hey, a database has been copied over. But we also ended up looking at the space taken by each table here and there. And it turns out that initially it sounds like a great parameter to compare against different databases. And when you're running the same versions, this is probably foreshadowing, those numbers are going to be super close to each other. But when you're migrating versions entirely, we realize that those versions are going to be in the same ballpark, but they can be different enough that you notice them. So they're not going to be like, yeah, a small difference. They're going to differ enough that you want to actually stop paying attention to those, and you just sort of look at the counts of rows, and you sort of look at the write ahead log. Was the thing, there's a pointer on the write ahead log, and you sort of compare that the pointer in the source and the target DB are at the same thing. And so this script essentially queried like, hey, give me the status on this node, give me the status on that node, and tell me if they're the same number. It's easy to do that in staging, but when you're doing it in production and when you've got like a downtime window, you don't want to be running queries manually. So I just ended up running this script, and that script was also set up in a way that it will keep post printing the output till it reaches the point where the numbers match and it exits. So that's sort of a sign to tell me that, hey, the replication is caught up. I can now just like cut over the application from the old database to the new DB. So that's sort of something that helped. And something that's super relevant for turn over here is this particular script was my first sort of proper experiment with LLMs for coding. I played around with ChatGPT and Claude gave me like a bunch of help and support in making sure this script worked. We ended up although all of the other stuff was written entirely in TypeScript, we chose Go for this particular case because it was super easy to build a static binary that I could just ship to one of the containers that is running in the VPC cluster, and I did not have to then open up the database to the entire world just to check the status of the replication.
Gotcha. That makes sense. And
Yeah.
uh, how was your experience with sort of, I think writing tooling for any kind of migration is a critical step to like build your confidence there. I want to
Yeah.
ask about the LLMs, but before that, I think it's really interesting to think about like what numbers have to match before and after to kind of validate that it's working. Did you find that it was just time you needed to get the numbers to match, or did you run into situations where there was a setup issue and like the number of rows never converged?
There were cases where the numbers did not converge. At this particular assignment, a couple of those happened because the tables had data either in the incorrect encoding or something of that sort. I'm sorry, I don't recall the exact specific, but the row was essentially not getting copied over from here to there. And after inspecting those particular rows manually, we realized that it was essentially test data that was not gonna be relevant for uh, the actual end users. It was still in production, but it was test data in production. So we chose to actually clean up the stuff from the source table and then run the migrations again. So that worked over there. At the previous company at Dite, we did have a couple of other cases where the numbers did not match for a little while. Um, and if I remember correctly, at least one of them was this was not an encoding mismatch, but this was still sort of in the same space. It was a data type mismatch, which probably was because application code which was running at the time of the row being inserted accepted that, but for some reason the newer database version was stricter about that validation, and then it said, "Hey, this is not gonna work, no bueno." So we had to fix those rows in the source DB and then copy stuff over.
Got it. Was it obvious from just the like looking at the rows what the fix was, or did you have to go dig into old application code or otherwise find context?
At Dite, we did have to work with a couple of the application engineers to figure out what was sort of not making sense, and then fix the rows. At the consulting assignment place, it was fairly obvious that, hey, this is test data because the names for some entries in the row were fairly obvious, like, hey, this is not a actual human, this is just a testing thing that's in there.
Got it. So you really had to go find that organizational knowledge about what the data was in the database before you could
Yeah.
either safely delete it or
Yep,
clean
yep,
it up
yep.
so you can migrate it.
Yep. Yeah, another thing that sort of relates to this, and it's probably going to be a tangent, so feel free to cut me off at that, is we found that there are a couple of tables, and this was the case in both the scenarios, where there's a ton of data, which essentially ends up being either analytics or usage tracking data that almost nobody ever ends up looking at. All of that is built out with good intentions. At some point of time, you want to track what's happening, and that data would also have been used at some point of time for a particular feature, but the feature got dropped and everything did not get cleaned up. So you're just carrying around a ton of baggage in the database, consuming all of these resources in the CPU, memory, and disk. So it's just easier to either prune that data completely or drop that table entirely, depending on the right situation. But
Yeah.
that is again knowledge that is not going to be very obvious when looking at, well, the decision of should we prune this, should we drop this, or do we need to keep this is something that humans know. It's not going to be something that a system can tell us.
Yeah. The table is in the database. You're migrating the database. You should migrate the table, but that's not always true.
True.
Um, how did you think about, as you're thinking about locking in progress, how did you think about deploying the changes as you went? You mentioned eventually taking a downtime window to do the cutover. As you
Mhm.
were working towards that cutover, how did you think about like locking in progress and continuously working so you didn't arrive at that point and have to start from scratch?
I'm gonna try to answer this. Please tell me if I'm going in the right direction. Um, as we approached the cutover, a couple of things that were so sort of super interesting for us was get a sense of which applications were only reading data and which were the applications which were writing data, and stuff that was reading data. You could possibly spin up a second copy. You essentially do a blue green deploy with the new database configuration and sort of make sure that nothing in the logs is obviously wrong. That gives you some level of confidence of, hey, the migration is actually working, the database is up to the mark. You don't necessarily want to have customer traffic directed to that directly, in the sense you do want to send the traffic in, but you don't want to send the responses out to the customers. Essentially reads and shadow writes is what you want to do and compare that data. But that is also sort of fairly mature infrastructure, so it may not always be present, and you have to take your best bet on with read replicas, or like with applications that read data only, and you sort of take a risk and sort of get a sense of, hey, this is working or this is not working. And at that point of time, you have to rely on your regular deployment tooling to quickly roll forward or roll back as required. That's at least what I found comfortable enough. Make your changes small enough and make them easy to deploy or roll back. And when you have that, you can run it in like the read only mode for a little while. You monitor stuff is okay. And then you sort of get close to the downtime window. At that point of time, you look at all of your write applications. Well, you've actually looked at them beforehand, but you look at them and you say, hey, this sort of needs a singleton during a cutover period to ensure that when data is being replicated from one node to the other, or we're sort of like when you're looking at something like a Kubernetes deployment for that service, you will always have n replicas of that pod. And you would get to a situation where some are talking to the old database, some are talking to the new database while the deploy is happening, and you will have inconsistent reads of the data at that point of time. So essentially, you can choose to just bring down the count of those replicas to one, and also make sure that the thread counts or database pool counts are also fairly predictable or low enough in this situation. And you monitor that. That's also going to cause issues for customers, but then that's where the usual downtime notifications end up helping. You need to send out communications to all of your customers, give them a heads up. Hey, these three features are going to always work. These two features will be running with a delayed response, and these other features will not work at all, or they might be incorrect for this certain period. Setting up those expectations is super helpful in this sort of a situation. And then you actually go ahead and do that migration. And if you've planned it out well, and if your writers are not stepping on each other's feet, you can have the cutover sort of happen at a point where you don't have data consistency or integrity issues. At the consulting assignment, because the website was a second channel or an additional channel for them, we could safely just shut down everything, keep an Apache or an Nginx thing running in the front end, sort of put a maintenance page for the 5-ish minutes that we were going to run that stuff. But for the previous space, we had to be a little more mindful about how we were doing the cutover.
I,
And like
I
those 5 minutes give you sort of, sorry, I'll just close this out. Yeah,
go for it.
those 5 minutes then give you the time to safely cut over, verify that the replication lag has caught up, and then open up the gates again. Yeah, that's it.
I like it. I love the idea of pulling the thread all the way out to the user visible application and saying what really needs to work. And in the case of the travel website, the answer is none of it. It's okay for 5 minutes. And
Yeah.
but in other situations that you might end up with a couple of key capabilities, and if you can just winnow the traffic down to a small enough number, then great. Then you can still take kind of a soft downtime without taking the core capability of the site down. That's a really interesting approach.
Yep, yep,
Let's come back to tooling.
yep.
You mentioned writing scripts in order to check correctness. Um, what was the most, and you mentioned LLMs in that process. What was the most effective set of tooling that you wrote?
Um, the thing that helped me verify that the replication lag is complete across different source databases. If you recall, I talked about how in the production setup there were 4 source databases in the lower version, and we ended up choosing to migrate all of them to just one node at the end. If it was like a one-to-one mapping, it's still fairly easy to just have 2 terminals open and run like a command a couple of times, like hit your up arrow, enter, and you like click over to the other and do that. But when you have multiple sources of data that is flowing in, or multiple sources of events. And the other sort of tricky scenario that this had been in was, um, because of legacy reasons, a couple of the databases were in an entirely different VPC. Like there was VPC A and VPC B of the source databases, and then VPC C was the new one, which meant running all of those queries from one location, which is your local machine, is not going to be super easy. So just having it in an automated manner run somewhere is a lot more reliable.
Yeah, I like that
Yeah, so there's
as a
that.
generic approach. That makes a lot of sense. But also, it sounds like this tool is very specific to this migration, right?
That ended up eventually happening. Like you can look at, well, there are generic parts and there are specific parts to this. When you're looking at something like a Postgres migration, which is definitely not going to be unique. There are metadata tables that you're interested in, which essentially tell you the count of rows. Those parts are, in fact, if you look up Stack Overflow and Postgres forums and a couple of these other locations, there are historical queries that people have put together. Some of them are fairly strong, complex unions. Strong is probably not the right word, but complex unions and queries that will give you the state of the source database. And you can run the same thing on the target database, and it will give you essentially like 2 tables to compare. So those parts are the generic parts. When it comes to the knowledge that, hey, this particular table is had bad data, so you're okay with only copying the first n things out of it, or this you can entirely drop data from here and not worry about it there. Those are like, that's still relatively easy to make generic enough, but the knowledge is going to be application specific, so you will end up customizing that.
Mm-hmm. That makes sense. Um, how much, as you were building these tools out, certainly some of this work is done manually and some of it is done with tooling. What's your philosophy on when is it worthwhile to make the investment in automation?
Oh, as a site reliability engineer, I think my answer is fairly simple. If I have to do a thing a third or a fourth time, then I'm gonna go ahead and automate it. If I'm gonna do it just once or twice, I will probably err on the side of doing it manually. Um, but when you're anyway talking about a lower environment and a customer facing or production environment, uh, it is fairly obvious that you're gonna at least do it twice, at least twice. But when you factor in all of the difficulties that a typical migration includes, there are going to be multiple failed attempts and then one successful attempt each in each of the environments, which easily bumps up the number to 3 plus or 4 plus. So if I'm thinking about migrations, this particular experience really drove home the point that maybe there is going to be generic tooling and maybe there is going to be specific tooling, but always look for opportunities for this and keep working on those opportunities.
Mm-hmm. That makes a ton of sense. If you're going to do it, at least twice, then, and you can be sure that you'll do it perfectly and there will never be a need to rerun it, then you can do it manually. But that's not how software works frequently.
Indeed.
Um, Looking back on this, and now that you've done this migration twice, maybe it's worth automating. What would the perfect tool for Postgres migrations look like?
That's an interesting question to think about. A couple of things that I would want to definitely keep an eye on and use like a tool to help me with is every database system ends up having tribal knowledge associated with it, which is the data that is actually relevant to the application, which is the data that is actually relevant to the customer. Those are two different sets of things. Like there will be overlap in these two answers, but they are different sets of things. And which of this data is relevant to the operators of the system, and which of this data is relevant to nobody. Those are sort of the categories that I would put it in. And a bunch of this data can be guesstimated by looking at all of the statistics that all modern mature database systems collect. How many queries are being sent, how many of them are read queries, how many of them are write queries, which of them go to which tables. Because we're talking about relational databases, I'm talking tables, but I'm sure something equivalent exists in the NoSQL world. um, it is super helpful to have educated guesses about which tables are important for the customer and which tables are important for the application. Because if you're coming in as an infrastructure person, whether you're coming in as a consultant or as a full-time employee or some other context, or a mixture of either of them, you do not always know the end to end of the user flow. So if you can get estimates on, hey, these are the 10 important tables, you can always prioritize your correctness checks for those. So any tooling that will help me answer which are the important tables and which are tables that were technical debt is something that I would definitely want to have for the next migration. That's an easy answer for me. I'm sure if I rack my brains hard enough, I might come up with another answer or two, but this is what I have right now as a wish.
But that's where you start. I think that's a fantastic insight, because I think it's very easy, if you haven't done one of these, um, to think that the hard part is moving the data, or some difference between the the old version and the new version. But as you're describing, the actual answer is why does this database exist for the purpose of the business? Why do these tables exist? And that's a much harder question, and does seem much more worthwhile to answer. Oh, I want to pick at that a little bit.
Sure.
Where does the answer to that question come from? Like, how do you know that? You mentioned a couple of things, but where do you need to go dig to find those answers?
Oh, yeah. So the database statistics are just going to be sort of the spark that ignites that fire. You still need to go and talk to, if you have like a very large setup, you'll go talk to the application engineers. They will have context. But if you're also a large setup, then most application engineers have deep knowledge but very narrow knowledge, if that makes sense. Like they have a lot of knowledge about their specific feature set, but they don't always entirely know how the rest of the thing works. And if you have a smaller place, then there's a better chance that talking to your application developers is going to be very fruitful. You should still talk to all of them. And then you also want to look at who is sort of the person who has the product owner role, and they can sort guide you towards the critical user flows. Another helpful thing at a mature organization is your metrics or your alerting or your SLOs are gonna already be covering what these critical flows are, and that will help you narrow down what or verify the data that has come on from your metrics and say, hey, these are actually the ones that are relevant for me. And then you go from there to like actually trying stuff out. Does that help? Is
Yeah,
there something else that
that
you were interested in?
that makes a ton of sense. How do you as you think about, like, you're almost pulling this up into a question of prioritization and organizational, like, desires. At some point, you need to flip it back down into, like, we're going to move this table and we're going to delete this one, or we're going to focus on
True.
these. Um, how did you manage the process of, especially as a contractor, coming in and making sure that you got all of that information such that you could do the right thing technically?
That's an interesting conversation. I think for this particular scenario, the answer is going to be a bit of a cop out. Um, because I had another partner, the person who was actually um, taking care of the application side of things while I was doing the migration at the infrastructure layer. Um, they sort of had the permission to go ahead and make changes as necessary, as long as the core functionality of the application did not break. Um, and that gave both of us the freedom to take those calls ourselves. Um, of course, we did verify that stuff with the CEO and the CTO roles in the company, the people who were holding those roles. But as long as we were able to make those changes in staging and have a couple of folks who were familiar with all of the workflows in the application use the staging application for a bit, and give us confidence that, hey, there's nothing broken here, we were able to go ahead and make those changes, take those calls of like, hey, this table can stay, this table can be pruned, etc., etc.
Yeah, for sure. It's at some point you have to pull the trigger, and you get all the information you can, and you start to pull the trigger and you validate it as you go. And if it all looks right, then all's well that ends well.
Yep, that's the
Very
hope.
cool. Um, so what's the state of the world now? You finished the migration, everything went peachy?
Oh yeah, the database migration went pretty painless. We ended up getting to a point where, like I mentioned at the beginning, we had multiple RDS instances, and all of them were like the only nodes or that had that data. Of course, RDS had the automated snapshots set up. So in the very worst scenario, you could restore from a backup, but that would mean a loss for the interim period where the snapshot had not been taken. We got to a point where we had two nodes, and another sort of uh, thing that we tried after the full migration had been done was we migrated the RDS instances from the legacy or classic x86-64 hardware over to Graviton hardware. And because RDS is essentially a managed service, you can mostly assume that, especially if your workload is classic CRUD workloads with REST APIs, that most of those workloads are going to give you a similar performance at usually a much cheaper cost. So that's sort of what ended up happening. Like, we migrated all of the data over to modern instances and modern versions, and then we went to cheaper versions. And we also were able to make sure that the parameters that were necessary for the larger spiky workloads were tuned for the newer database version, and stuff has been running fine. There have been no database related incidents since then. There were a couple of incidents that happened at that place due to new code being rolled out, but that was not due to this particular migration.
Awesome. Glad it all went smoothly. Um, all right. We're just about out of time. So this is fantastic. The answers you have around all of this are amazing, and sounds like a really positive experience for everyone involved, which is not always the case.
That is true.
um,
That is true. I was fortunate that I've seen a bunch of database migrations before, from the sidelines. This was the first couple of times that I actually did those migrations myself. So there was some support back in there.
right on. One final question: Where do you see what are you most excited about in technology right now?
Oh. Um, well, one is, of course, the work that I'm doing right now. I work with a company that makes it super easy to, well, do what we're doing right now, which is talk to each other across continents and oceans. We essentially make WebRTC as a service, and I'm always super excited about making it easier for people to work with each other or just interact with each other, and that just makes the world a better place. That's always something that excites me. And that, if you look at, sort of like you mentioned it at the beginning of the conversation, I've pretty much worked in productivity companies of some form or the other, whether it was mail or chat applications or video communication applications. That sort of is always something that I enjoy working in. And the other thing that I'm really looking forward to is, um, we did briefly touch upon this. LLMs have their faults, but they also make it super easy for prototyping ideas and getting stuff out there. And people have a bunch of different ideas that they have not been able to explore and experiment with because writing code and dealing with systems is hard. LLMs don't make all of that easy, but they make at least a part of it easy. They make it easy to prototype stuff. So I'm really looking forward to all of the cool ideas that people build out. And I know this will sound very cliched, but I am currently optimistic about it.
I absolutely agree. I think there are a ton of rough edges and a ton of difficult strengths and weaknesses of LLMs that we just most of us haven't internalized yet. We don't know how to use this tool, but there's not a technology that I've been this excited about in a very long time.
True.
So we'll figure it out.
Awesome. And looking forward to what comes out of this.
Absolutely. Finally, if folks have follow-ups, where can they find you on the internet?
Um, they can find me on Mastodon, where I'm the most active. I'm happy to put links in to show notes or wherever it makes sense. I have a blog which I infrequently write on, and there's also X or Twitter, which I check infrequently, but that's probably the easiest way for people to reach out to me.
Great. We'll include those links.
Awesome. Thank you.
All right. Thanks so much, Ninad. This was fantastic.